Yeah, coming to size and number of units finding. So I'm keeping the load here like this. So what is the criteria? Yesterday I told you size and number of units. The criteria is to fit in the load curve as closely as possible. To fit in the load curve as closely as possible. So where is the load curve here? The load curve I have drawn here. You can see this one. Okay, this is the load curve. In this load curve, these are the load 12 to 5 a.m. 500, and then 5 a.m. to 10 a.m. 800, and 12 to 10 to 12, that is 2000, 12 to 2, that is 1000, then 2 to 5 highest load 2500, and then next 2 to 5 to 8 p.m. how much? 2000. Here 2000 and here 2000 is coming. So remaining all, this is 1500 and this is 1000. Now this, for this load curve, in order to fit as closely as possible, what are the generators you can take? Can you take 2500? 2500, if you take one generator, only it lasts for how many hours? 3 hours. So it is not the thing. So if you take 2000 also, 2000, it lasts also 2 hours. So it also cannot be taken. So as closely finding, you can see 1000 is coming, 1500 is coming, and here 1000 is coming, and 2000 is coming, 2000 is coming. Here 1500 it is there, 1500 is there. Here 1000 is there. So by closely finding, we can take as closely as possible to this also. By taking this load, the generators which we can take are this one. So what are the generators you can take? One is 1000 and another is 1000 and another is 500. These are the generators we can select for this load. If you take 500, it is suffice. 1000, it is suffice. Here two 1000s, here 1000, here 1000 and 500. So here 1000, so we can here 1000 and 500. So we can switch on and switch off according to this time, and we can maintain the load curve. So how many generators are needed here? 1000, and another generator is 1000, another is 500. So how many generators? 3. And also here one more point, we want continuity of supply. So in order to continuity of supply, backup is needed. That backup is called another name, reserve capacity is needed. So what is the reserve capacity equivalent? How much? The reserve capacity equivalent to the largest unit which is there. The reserve capacity is equal to the largest unit. What is the largest unit? Here 1000. So reserve capacity is 1000. So what is the total capacity now? Here 1000, 1000, 1000. So 3 of 1000s and plus 500. So the total capacity is 3500. Now the plant capacity factor. The plant capacity factor, already we discussed the formula. What is that formula? Actually it is generated by the maximum energy that could have been generated. That means maximum load into time into reserve capacity also we have to take into consideration. So if you take time into common, then it will be total capacity into time. Okay, what is the total capacity? 3500. What is the normal maximum load? 2500 plus reserve capacity 2500 is the maximum load. Is it? This is the max plus reserve. What is the reserve? 1000. So 3500 into 24. So the plant capacity factor is 36.9%. In the next video I am going to find, I will teach you to how to find the plant use factor. Okay.